Welcome to this technology update on Road Oil Resin Modified Emulsion, presented by Soil Stabilization Products Company, Incorporated, your source for environmentally appropriate product technologies for pavement construction, dust control, erosion control, and soil stabilization. Road Oil Resin Modified Emulsion is a non-petroleum, high bonding strength emulsion developed specifically for the construction of pavements, for dust control, and for erosion control.
For pavement applications, the non-water soluble road oil emulsion is mixed with aggregate materials already placed on grade, or combined with the aggregate at a central mixing plant and placed with a paving machine. Similar to construction of asphalt pavements, compaction equipment is used to produce dense, smooth-running surfaces. Road oil can be diluted with water for applications where surface penetration is essential. Surface penetration is often the method of choice. For dust control of unpaved roads, traffic surfaces, road shoulders, runways, and helipads, for erosion control for areas of bare earth and material stockpiles, and for prime coats, tack coats, fog seal, and surface seal applications. For all these applications, the road oil resin modified emulsion is applied without the need to heat the product or heat the application equipment. Working with a cold-applied product saves on energy use and protects air quality while also simplifying application. Interestingly, road oil easily outperforms conventional hot-mix asphalt and hot-applied asphalt emulsions when measured by stability and strength tests standardized for pavement mixes with asphalt binders. In fact, road oil resin-modified emulsion provides the most concentrated form of binding power available for pavement, dust control, or erosion control applications. Gallon for gallon, liter for liter, road oil sets the performance standard. Given all that concentrated strength, it's no wonder road oil resin modified emulsion has been air freighted around the world for special project requirements.
How can an environmentally friendly product provide such performance? Well, it's a matter of combining fractions of natural tree resins by use of advanced emulsion technology. These ingredients have tremendous adhesive properties when formulated in this manner. For a parallel example in nature, take a look at amber, translucent chunks of hardened tree resins that exhibit incredible stability over periods of time measured in millions of years. As focused on in the movie Jurassic Park, insects have been found entombed in 30-million-year-old amber, still fully intact. Now that's a durability record that any construction professional might rightly pause to appreciate. And road oil is formulated from the same family of highly adhesive resin compounds as amber.
Tree resin ingredients are a good start, but when it comes time to create a modern, high-performance binder for pavement, dust control, and erosion control applications, the selection and proportioning of ingredients and the manufacturing process are all equally important to delivering the workability and coating characteristics that an emulsion product must have to provide super high bonding power. Road oil's resinous cementing ability is powered by high rosin content. Rosin is a primary ingredient in a myriad of construction adhesive and sealing products, and its incorporation in the road oil formulation is fundamental to the product's consistent record-setting performance in pavement materials testing laboratories and in field applications where bonding and sealing capabilities are really put to the test. Traditional asphalt emulsions and most other emulsion products require an electrical charge to exist as emulsions and to perform their ultimate binding task. Unfortunately, these charged emulsions, also known as cationic or positively charged, and anionic or negatively charged emulsions, come with a long list of trade-offs such as limited stability in storage, extreme sensitivity to the chemistry and clarity of dilution water, and sensitivity to the surface chemistry of aggregate materials. In addition, charged emulsions are subject to a problem which is referred to as zeta potential, a phenomenon in which the emulsion strips away from the rock components in an aggregate mix and coalesces with the fine particle materials into small balls, resulting in poor performance as a pavement binder or a surface penetration treatment. Cationic and anionic formulations, therefore, have limited ranges of application and deliver only a fraction of road oil's bonding power. Road oil is advanced emulsion technology. No electrical charge is required. This non-ionic or neutral state allows for maximum penetration and coating of aggregate and soil materials, as well as excellent workability for mixing operations. All these factors contribute to exceptional performance. The bonding forces of amber have been mobilized by modern technology.
Before we focus on dust control and the other types of applications normally handled by surface penetration treatments, let's take a more in-depth look at the performance characteristics required for effectiveness in all these uses: bonding strength and elasticity. We can use standard pavement materials testing to compare road oil in these categories to products with which almost everyone is familiar: asphalt and concrete pavements.
The Marshall test method is the traditional approach for determining pavement mix designs. Mix designs are done to evaluate a number of variables, with primary emphasis on selecting the appropriate percentage content of binder for a particular aggregate. Pavement samples are first prepared and then subjected to a series of tests. The primary two, stability and flow, are measured in a test frame with a split breaking head.
Stability is a measure of bonding strength and is measured at the breaking point as an increasing load is applied to the specimen, similar to an unconfined compressive strength test for Portland cement concrete, or PCC. Flow is a measure of the elasticity of the specimen as it is loaded. This is a test specific to flexible pavement materials such as hot mix asphalt, or more properly, asphalt concrete, or AC. A flow meter is used to determine the amount of movement or strain occurring between no load and the maximum load for the test.
As you will see, road oil resin modified emulsion is in a category all its own when it comes to bonding power. With proper aggregate selection and attention to mix design, road oil pavement mixtures demonstrate stabilities that approach the strength of Portland cement concrete while maintaining the flow or elasticity characteristic of asphalt concrete pavements.
Today, in addition to Portland cement concrete and asphalt concrete, we have resin concrete, or RC, a material category made possible by the road oil resin modified emulsion technology. Using the Marshall design criteria standardized by the Asphalt Institute for hot mix asphalt concrete and asphalt emulsion pavement construction, we can provide a comparison in bonding strength between asphalt binders and the road oil resin binder.
Stability criteria are provided only as minimum limits. Limits which increase as traffic classifications are upgraded from light traffic to medium traffic and to heavy traffic. Stability criteria range from a 750-pound minimum for light traffic up to an 1,800-pound minimum for heavy traffic. Expressed in metric units, that range is from 3,336 newtons to 8,006 newtons. While standard asphalt mixes rarely demonstrate stabilities even 50% above the minimum stability requirement for the heavy traffic classification, it is normal for road oil resin concrete pavement mixtures being evaluated by independent testing laboratories to produce stabilities that exceed the minimum stability requirements by 2, 3, 4, 5, even 6 times. It's not uncommon for road oil mix designs to exceed stability values of 10,000 pounds, or 44,500 newtons, while still maintaining the flow or elasticity characteristics standardized for hot mix asphalt pavements. Road oil resin modified emulsion clearly sets a whole new standard for bonding power, and that's important news for dust control and erosion control, as well as pavement construction. Dust control, erosion control, and surface penetration treatments must resist many of the same forces as pavements. To be effective, a treatment has to endure exposure to varying degrees of sunlight, rain, wind, temperature, and moisture fluctuations, as well as foot or vehicular traffic. Bonding and sealing performance are interrelated and essential to economical, long-lasting performance in all these applications. Road oil is used for a variety of surface penetration applications, which include dust control, erosion control, prime coats, fog seals, and surface seals. While road oil is produced as a non-water soluble emulsion, which cures to provide permanent bonding, the emulsion is normally diluted with water in preparation for treatments which involve application to previously hardened or compacted surfaces. Dilution ratios vary according to project requirements.
Let's take a brief look at use of the road oil resin modified emulsion for erosion control treatments. We are watching an application by a truck-mounted hydro-seeder unit, which is the preferred equipment for applications on steep slopes or areas where equipment cannot operate directly upon the surface to be treated.
This is a protective treatment being applied to military bunkers after a slope stabilization installation of a cellular confinement system. And here's an application at an asbestos waste dump site. Road oil was selected as the treatment for the sandy soil cover by state regulators who are aware that dust control and erosion control protection would be necessary for the period of several years or more, required to plan, permit, and implement final disposal.
Let's focus now on roads. As you might have guessed, the road oil product is no stranger to dust control programs for heavily trafficked, unpaved roads. The formulation was originally developed as a maintenance treatment for mine haul roads. The ability of the road oil treatments to retain aggregate surface materials and shed water off the road surfaces was a welcome advance over products providing only short-term dust control. Road oil is effective for other heavy-use applications such as industrial yards, unpaved runways, and landfill access roads, as well as more general applications such as rural roads and city streets.
Let's stop for a minute and address the economic and environmental impacts of untreated aggregate and gravel surfaced roads.
Dust is often the most visible problem on unpaved surfaces as it is an obvious safety hazard. The health hazards of breathing particulate matter are well documented. PM10 standards developed by the United States Environmental Protection Agency address the need to control fugitive dust emission from unpaved roads. The loss of surface fines from dusting and water erosion contribute to sedimentation of streams, rivers, lakes, and bays. Sediments are the major form of non-point source pollution. The U.S. Environmental Protection Agency directly targets the stormwater discharge problem area in the NPDES, the National Pollutant Discharge Elimination System, regulations. Untreated aggregate or gravel surfaced roads rarely provide running surfaces of consistent quality. Road users as a group suffer very high maintenance costs for cars and trucks operated on these roads. Road owners are caught in an endless cycle of road grading and gravel replacement. In many areas, yearly loss of gravel due to dusting, water erosion, and maintenance grading averages an inch or 25 millimeters and more.
Calculate replacement costs for gravel loss and grading maintenance, and it becomes apparent that money is available for treatment programs that stop dusting and hold surface materials in place on a year-round basis. Solve these problems, and there's a high probability that good roads and environmental compliance can be achieved as an additional benefit rather than an additional cost.
Let's take a look at some road oil applications on runways, helipads, and roads. This aggregate surface runway was graded, pre-watered, and then protected by a multi-coat application of road oil. The initial coat was a surface penetration of the untreated aggregate. The following day, a road oil coating was again applied, this time as a surface seal designed to further harden the runway for service under C-130 landings and helicopter touchdowns.
This runway shoulder treatment has been applied to prevent dusting and foreign object damage to aircraft. The road oil treatment remains undisturbed by jet blast, even though it's being tested here during the earliest stage of curing. While bituminous distributor or spreader trucks are the preferred equipment for normal surface spray applications, pressurized water trucks are often used for smaller projects, such as this surface penetration for helipad dust control, or for projects at remote locations, such as this surface seal being applied to a stabilized aggregate at a remote runway.
There are several reasons why road oil is especially well suited for landfill road maintenance and dust control. Landfills have strict regulations, which include requirements for dust control. Many landfill roads have to be moved every few months or years, yet these temporary roads must perform like permanent roads year-round under the constant traffic of trucks and construction equipment.
At this high-volume municipal solid waste landfill in the central U.S., operated by a private waste disposal company, light surface penetration treatments applied with their own water trucks a few times a year have created a running surface that is no longer subject to dusting. Wet weather rutting problems have also been eliminated by the sealing effects of the road oil treatment. At this hazardous waste landfill, road oil is used as a surface penetration treatment for dust control on secondary roads and mixed in for full depth treatment on heavily used main access roads and equipment service areas near the shop. This dual-use type of application is typical and exemplifies the versatility of the resin-modified emulsion technology. Another landfill uses surface penetration application on all of its roads, except for one very sharp curve where road oil is mixed full depth with the aggregate and then compacted to create the shear resistance and tensile strength needed to withstand the tight radius turning action of fully loaded trucks.
Some people think the state of California sets the world standard for aggressive environmental regulation. In Sacramento County, home of the state capital, environmental suitability is indeed a serious issue. When it came time to select a treatment for road maintenance and dust control, road oil was the only product that satisfied both environmental and operations staff. Road oil is applied on landfill roads on an as-needed basis, and it provides year-round service, holding the road surface and providing dust control in dry weather and sealing the surface off from moisture penetration during rains.
While many dust control and erosion control applications can be handled with surface penetration treatments, it is equally common to find unpaved roads and traffic surfaces that need a greater depth of treatment and compaction to adequately bind the surface materials into a durable running surface. Applications of this type are normally characterized by strict budget constraints, which restrict the buying power needed to purchase hot mix asphalt or suitable quantities of road oil emulsion to construct a permanent pavement. Road owners realize that they are far short of having a paving budget, but they also want the best value available when it comes to dust control, to reduction in maintenance frequency, and to quality of running surface. Road oil resin modified emulsion provides an effective binder for these road mix type applications. In the absence of budgets to run laboratory mix designs or to purchase adequate product to meet pavement stability standards, application rates and construction procedures are often determined by existing local experience or by construction of test sections in preparation for full-scale construction. Similar to pavement applications, aggregate materials must first be brought to an appropriate moisture content before the undiluted road oil emulsion is applied and mixed with the aggregate. Thorough mixing and proper compaction are essential to performance.
In all the applications we are looking at here, roads at a wastewater treatment plant, a Forest Service road, streets through a rural town, among other applications, road oil is being processed with aggregates of varying quality and consistency that are already in place on the roads. When working with marginal materials that don't meet strict gradation standards, or aggregates which have been degraded under use on the road, the neutral chemistry or non-ionic formulation of road oil resin-modified emulsion is a real plus. These situations require an emulsion with maximum workability and excellent coating characteristics in order to provide effective bonding.
2 projects on National Forest roads are a case in point. These aggregate surfaced roads were both subject to excessive dusting and erosive loss due to their high percentage content of fine particle materials and lack of cohesive characteristics. In both cases, erosion control of road surfacing materials was of equal or greater importance than dust control due to the sensitive trout stream habitat very close to the roads.
The first road ran through a high mountain meadow, intersecting a creek with beaver ponds and full of endangered trout. Road oil met agency criteria for an environmentally friendly, non-asphalt treatment that could be mixed in place at this sensitive, remote site. The second project was just upstream from a state fish hatchery. Road surfacing materials had been crushed from mine waste rock years ago. Heavy metal contamination of the aggregate was later discovered, potentially contributing to downstream fish kills and clearly creating air and water quality violations at the site itself. As an immediate remedial measure, road oil was applied to the primary road, providing dust control and erosion control during the period of years until final cleanup measures could be implemented. use of a non-petroleum binder kept all options open for final disposal or treatment of the contaminated aggregate. Road oil mix designs are being evaluated as options for construction of permanent pavements that will be placed to encapsulate the contaminated materials on adjacent roads included in the project.
As we have seen, road oil resin-modified emulsion lends itself to difficult bonding tasks due to its advanced non-ionic formulation and concentrated bonding power. Reclaimed asphalt pavement millings, or RAP, provide one of the largest volumes of recyclable material available. Although conventional binders have not been highly effective in restoring RAP materials to suitable stabilities for use again as pavement surfaces, road oil has the bonding power required.
A road department with their own pavement materials testing lab ran Marshall test mix designs using road oil as the binder for treatment of their reclaimed asphalt pavement millings. While they were able to achieve pavement surface stability suitable for heavy traffic in their lab testing at relatively low road oil treatment rates, they chose to push the limits of the resin-modified binder when it came time for field construction by using an even lighter application rate, as if they were going to use the treated mixture for base course construction. Once in place, however, the compacted mixture performed so well that it was left as a pavement surface without the benefit of even a protective chip seal surface treatment. Under the severe stresses of high-altitude surface, freeze-thaw cycles, and snowplow operation, the road oil-bound asphalt millings provide a pavement that is hard to distinguish from a virgin hot mix asphalt pavement. Recycling of asphalt millings is just another application for this versatile resin-modified emulsion.
We have concentrated up to this point on technical issues relating to product formulation and performance and on field applications of road oil resin modified emulsion. Make no mistake, this product stands on its own when it comes to cost-effective service and performance under the most challenging applications. In fact, when this resin-modified emulsion is used as a pavement binder, the performance characteristics are so unique that they define a new classification of pavement materials, resin concrete, or RC pavements.
It's impossible to discuss road oil resin-modified emulsion without also directly addressing the fact that it is an environmentally friendly technology, one that provides an alternative to much less appropriate products in common use. Road oil resin-modified emulsion has been reviewed and approved for use by the environmental staff of federal, state, and local agencies, as well as private sector industries, for use in the most environmentally sensitive locations.
In addition to domestic use, international shipments by U.S. military organizations testify to both road oil's credentials and to the military's commitment to provide leadership in the implementation of environmentally friendly technology whenever and wherever possible.
While most people don't realize it, some of the most sensitive environments in the world, at least as far as environmental regulation and monitoring goes, are industrial applications such as petroleum refineries, petroleum production and pipeline operations, landfills for municipal solid waste, and landfills for toxic and hazardous waste. These facilities need clean technology to remain in compliance. Road oil is increasingly being used at these facilities for maintenance of roads and parking lots, as well as for treatment of containment berms and other areas where bare earth must be maintained without vegetative cover.
Projects in protected natural areas or at military and industrial facilities may not seem close to home for everyone, but with enforcement of environmental regulations for air and water quality becoming a reality, along with soil conservation and occupational safety requirements, the time is here to bring cost-effective, environmentally friendly products into service in another sensitive environment, the place where we live, work, and play every day. Road oil resin modified emulsion is here to help protect the quality of our future environment.
What else do you need to know about road oil resin modified emulsion? Road oil is manufactured by Road Products Corporation.
The product is available in drums and palletized bulk containers, as well as bulk truck and rail car quantities, and in ISO containers, which can be barged and ocean freighted for remote projects and international shipments.
Further information is available from Soil Stabilization Products Company, Incorporated. Let our experience in construction technology,
Dust control,
engineering,
environmental science,
erosion control,
estimating,
pavement materials production,
and soil stabilization
work for you. We look forward to being of service.